Hi, today's introduction is on polar coordinates and polar equations. So for this next topic, we're going to be working from Chapter 9 in their textbook, Sections 5 and 6. Graphs for polar coordinates and polar equations are pretty cool looking. You get these all kinds of pretty graphs with your rose curves, and you can even do ellipses and hyperbolas. They're all in this kind of circular system that we're getting ready to learn a little bit about. What we know right now is we know about our rectangular point system. That's the Cartesian coordinate system, that grid of XY values that you've been studying for a very long time since you started learning how to plot points. And they have the positive axis, the negative axis in both directions. So this point would be 2, 2, and we describe it as a horizontal distance 2 and a vertical distance 2. And so this is where we begin our topic of graphing. However, just because it's the first way that you're taught it doesn't necessarily mean it's the best way to do it or the easiest way to do it. For instance, if you were to ask a kid that was out playing for the summer or riding around on their bike where they left their bike at, they might just say over there and point to a direction. And so basically they're describing, although very basic, the distance, that's the just, and the direction over there. So it might even be punctuated with a head nod or pointed with their arm. When you ask someone where they live or where their town is, they're going to say something like, "We live 30 minutes north of Dallas," or something like that. Again, a distance and a direction. It's not very often that someone gives you longitude and latitude coordinates, which would be more like your Cartesian coordinates. We typically use distance and direction to describe our position. And this is the method that is used when you're talking about polar coordinates or even bearings that we have previously studied. So in our polar system, the graph is a circular system, and it is a system that uses just what we talked about, a distance and a direction. So for instance, this 2 pi over 4, the 2 represents the distance, that's what's along this ray, and the pi over 4 represents the angle, which is the ray. And so that's how we graph when we're graphing in polar coordinates. We graph a series of points called r, theta. Polar coordinates, there's some new words that are going to kind of come out during this topic. The first is the polar coordinate itself, which is an r theta instead of an xy. You're going to have the polar axis, which is this axis down here that is on the positive x-axis. That's called our polar axis. We have the pole, which is the center or the beginning of this graph, and in the Cartesian coordinate system we would call that the origin. And then you have this directed distance that runs down this ray, and that's our r value. And then the distance from the directed angle is the distance from the polar axis all the way up to where that directed distance or that ray is. So it's a little different in that regard. So again, distance and direction. So one thing that's very different from polar coordinates to other coordinates is, in the Cartesian system, 2, 2 is a specific point. In the polar coordinate system, that one point can have multiple representations. There can be lots of ways to name that point. Just like when we named our angles, we could go in the positive direction and label it as a positive angle, or we could go in the negative direction and get a negative angle. Well, just like that in polar coordinates, we can have negative or positive degrees. We can have negative or positive angles. So this point on this graph, which is 3 pi over 4, all of these points could be used to represent that. So we'll have to learn how to do that and practice doing that as well. We will also be working with equations. So the first 3 equations are examples of polar equations. R equals 2, theta equals pi over 3, and r equals secant theta. These next 4 are your rectangular equations, and that's the equations that we've been using so far. So you get y equals x squared, which is a parabola, y equals 4, which is a horizontal line at 4, x equals 8, which is a vertical line at 8, or even a circular equation, x squared plus y squared equals 4. So sometimes we need to go back and forth between the 2 kinds of equations, so we have some conversion factors. So when we do polar to rectangle, we'll use these conversions, and if we do rectangular to polar, we'll use these conversions, and these can be found in your book. When you look at the calculator, it does definitely look different when you're in polar mode. So remember that we normally stay in function mode, but if we want to go to polar mode, which is right here on the home screen or that mode screen, we would press the mode button, we would arrow down 3 times, arrow to the right 2 times until we get all the way over here on top of the word polar, and then we would hit enter. When we do that and press our y equals, we're going to see a menu that looks like this. So instead of y1, y2, y3, we have r1, r2, r3 down to 6. So there's not as many places to graph polar equations, you only have 6 spots. If we press the window button, it's going to look a little different as well, because this time we have thetas, x min, x max, x step, and we have x min, x max, x scale, and y min, y scale. So you're going to have the window is going to look a tad bit different when you're in polar mode from function mode. If you are graphing, they're definitely going to look different. The equations, I graphed the same equation in both rectangular and polar form so that you could see what they look like. So if I press y equals in function form and I type in y equals sine 2x, then I'm going to graph from 0 to 2 pi. So the x min is 0, x max is 2 pi, x scale is pi over 4, and then my x and min max. So I get this graph right here. So I labeled the parts above and the below the axis just so you could see how they relate to the same type of equation graphed in polars. So if I graph it in polar, when I go to my polar mode, remember it's going to say R1, R2, R3, R4, R5, R6. So I type in 5 sine 2 theta. And then when I go to my window, I'm still going from 0 to 2 pi, but notice it's not the same angle that I'm counting for. Typically, the bigger steps in between on polars, this starts looking like flat. So like little diamond points instead of curvy points. So usually our t-steps are going to be a little bit smaller so we can plot points closer together so we can get that nice pretty curve that you see on this petal. And so area 1 in the polar graph was this area 1 that was above. Area 2, which was below, is below here. Area 3 moves on around into this quadrant, and area 4 is back around there. So you can see they look very, very different. So we'll work on graphing, converting between the two, and how all of that's going to look on this lesson, these lessons. Then we have just some basic polar type graphs that you will need to kind of learn about and learn how to work with them. So as we go through this, we'll talk about it. These are the basic ones, and then depending on the orientation of the axis or the pole axis, whether it has the type of symmetry it has, will kind of depend a little bit on what it's going to look like. So these are some basic ones. We have the limacon with a loop in the middle. We have a cardioid, which looks like a heart sideways. We have a dimpled one, which kind of dimples in right here and flattens out. And then we have convex, where it's moving out here, it's kind of flattened out. We have rose curves, which are kind of fun because you get these really pretty pictures of flowers. So you could have flowers and petals that are symmetric with respect to the pole axis or the pi over 2 axis. You could change the length of the petals and make them longer. You can change whether the petals are oriented on the axis or not on the axis. So this is oriented around the pole axis, where this one is oriented around the pi over 2. Changing that a value changes the length. So those are some rose curves. And finally, we have the circle, which now you can see is oriented around the pole axis, or it could be oriented around the pi over 2 axis. And then a limescate, which is the figure 8 looking one. And it could be on the diagonal, or it could be definitely horizontal. So those are the different kinds of polar graphs. So we will have a help sheet that we'll put up on Canvas that you can refer to for these graphs. And those are the things that we're going to be doing. So we're going to take a couple of days here. Today is the first day you're going to do, is just kind of, today is introduction. Then you're going to have a lesson on working with the coordinate points. And then you're going to have a lesson on graphing and working with the equations. And then we'll kind of practice it all together. So this is kind of a fun unit with some really cool pictures and drawings, and I think you'll find it kind of fun. Thanks, guys. See you next time.